Okay, so today we're going to be doing the 2020 AMC 12A problem 24. Sorry for not posting the past 2 weeks. I was sick with COVID and I have midterms coming up, so I've kind of been really busy with as well. But I was just hoping to get a quick video out this week. So the problem says, suppose that triangle ABC is an equilateral triangle of side length S with the property that there is a unique point P inside the triangle such that AP equals 1, BP equals the square root of 3, CP equals 2. What is S? So I've drawn out the diagram here. We have AP is 1, BP is root 3, and CP is 2. ABC is an equilateral triangle. So the first thing we might notice is that these lengths, 1, 2, and root 3, where have we seen them before? Well, we've seen them in a 30, 60, 90 triangle, because in that triangle we have lengths x, x root 3, and 2x. But in this diagram, we can't really make a 30, 60, 90 triangle because, I mean, all the segments are pointing in opposite directions. So one thing we can actually do, and this is actually a really cool trick, we can rotate this diagram 60 degrees counterclockwise and just hope that something works out. So point P, this will get reflected over here. Let's call this new point P prime, and let's say that this will be 60 degrees. If we rotate A 60 degrees counterclockwise, that's just going to be the point B, because in an equilateral triangle, each angle is 60 degrees. So we can call this point A prime. And finally, we have our last point. I'm just going to erase this really quickly. We have our last point where we rotate B 60 degrees counterclockwise. So that'll end up about here. So I'll just draw in these lines just to make them easier to see. This will be B prime. And let's just draw in these segments. We know that this is going to be 2, because this is the same as this segment CP rotated. This will be A prime P prime, which is going to be the same length as AP, which is 1. And finally, B prime P prime is going to be the same length as BP, which is the square root of 3. Okay, well, let's look at this triangle here. If we draw in this length here, P prime, we know that it's isosceles, first of all, because CP equals CP prime, which is 2. And we also know that the top angle is 60 degrees. And these two base angles must be equal, which means they are also 60 degrees. And that means that this length PP prime is 2. And now let's just look at the diagram and see what we have. You might just stare at it for maybe a few minutes and then finally notice that we actually have this triangle here, B, P prime, P. We can see that our side lengths are 1, 2, and root 3, and that makes the side lengths of a 30, 60, 90 triangle. So that means that we're going to have a right angle here. And this angle, will be 30, and this one here will be 60. Okay. And we want to find the side length of ABC. So notice that we have this triangle here, CP prime B, or A prime, we have this angle which is 120 degrees, and we have two side lengths, 1 and 2. So we can use law of cosines to figure out the last side length, AC, or sorry, A prime C. So we have A prime C squared is equal to 1 squared plus 2 squared minus 2AB, which is 4, cosine C. Cos 120 is negative 1/2. So that's going to be plus 2, because negative 4 times negative 1/2 is 2. And then so we have A prime C squared, which is S squared, equals 1 plus 4 plus 2, which is 7. So S is just going to be the square root of 7, and that's going to be B. So I hope that was a simple solution that was easy to understand, and I'll see you guys in the next video.